This is lesson 6.2, solve linear systems by substitution. So a lot of you are watching this video because you're in first or third period and you're doing your air testing for language arts today. So you're going to watch this video and then make sure you take good notes. And then tomorrow you'll do an assignment related to the video. So we're going to do our first example. So solving linear equations by substitution. So the idea is you have two equations with two unknowns, x and y, and you want to make it so that you have one equation with just one unknown. So you want to find a substitution you can make in one equation and substitute that in for the variable in the other equation. So for this equation, if you have y equals just a number and then an equation, we can just substitute in 6 for y in this equation. But I'm going to walk you through a couple steps just to explain the thinking process. So we know the y is equal to 6. And where we see y in the second equation, we're just going to plug in 6. So we'll have 2x plus, instead of y, we plug in 6 equals 12. And then we're going to just solve for x. So this is a two-step equation. You would subtract 6 on both sides. So you get 2x equals 6, divide by 2, and you get x equals 3. And just like the other systems of equations, the solutions are the coordinate where they intersect. So if we were to take x equals 3 and plug it back in for x up here, well, you would get 2 times 3 plus y equals 12. This would be 6. So if you subtract 6 on both sides, you get 6. And then, but remember that we already knew what y equals. Y is equal to 6. So we actually didn't even need to do this. So here are the solutions. We already know y equals 6. So the solution would be 3, 6. Okay, here's a second example. So step 1 is to solve the equation for one variable. So here, the second equation is already solved for y. So it's y equals 3 plus x, or you can write x plus 3, doesn't matter. Okay, so then you're going to substitute in 3 plus x for y in this equation, in the other equation. Don't do the same equation because that will just give you 0. Plug it into the other equation for y. So we're going to rewrite the second equation, but instead of y, we're going to write the expression 3 plus x. And then we're going to take this equation and just simplify it and solve for x. So that would make 2x plus 3 equals 5. Subtract 3 on both sides, and you get 2x equals 2. Divide by 2, and you get x equals 1. Now for this one, we do have to plug 1 back in for x. We can do either equation, but the one where we already solved for y, that would be easier. So if we did 3 plus 1, that would give us 4. So then the solution would be 1 for x and 4 for y. That's where they intersect if you were to graph them like you did yesterday. All right, so this one, the first equation is already solved for x. So it's 3 minus y. So where we see x in the second equation, we're going to replace it with 3 minus y. Because right now we can't solve an equation if it has two variables in it. But if we can get them both to be y, then we can solve for y. So we're going to take x plus y equals 7, replace x with 3 minus y, and then simplify. So this is 3, and then negative y plus y cancels out, and you get 7. Well, wait a minute. Does 3 equal 7? No, because this is not true, or because this is, oh, hold on. What do they want us to say here? Okay, yeah, because this is not true, this system has no solution. So this would be an example. If you have no solution with two lines, that means that they are both parallel. So in this example, we have parallel lines. I don't think we had any examples like that in yesterday's Edulastic with graphing. All right, let's do a fourth example. So here we're gonna, now neither of these equations are solved for y, so we're gonna have to do that ourselves. So it's gonna be easier to solve the first equation for y because there's nothing being multiplied by it. So whichever equation has x or y that's like by itself, then solve for that variable. So let's solve for y here by subtracting 2x. So then y is going to be equal to negative 2x plus 4. So we solve for y. Now we're going to substitute negative 2x plus 4 in for y in the other equation for y right here. So I'm going to write 4x plus 2. And then since this is an expression and not just one term, we have to put it in parentheses. So negative 2x plus 4 is replacing the y variable. Okay, so now we're going to simplify. So distribute the 2. So 4x plus, well, that would make negative 4x. And then 2 times 4 would be 8 equals 8. Your x's cancel, so you get 8 equals 8. So does 8 equal 8? Yes. So if you get something that is true, so if the variables cancel out and you get that 8 equals 8 or number equals the number and it's true, then it would have infinite solutions. So what would the lines look like on a graph if it had infinite solutions? They would actually be like the same exact line. So you'd have a line and then the same line. So the same slope, same y-intercept, same line. They could appear different at first because they could be equivalent equations, but after simplifying, you'll get that they're the same. All right, and then let's do another one where you have to solve. So for this example, I would solve for x in the first equation. You can either solve the first equation for x because it's by itself. So I'm going to subtract 3y. So you get x equals negative 3y plus 7, or you could do 7 minus 3y, it doesn't matter. All right, so then we're going to replace the x in the second equation with this x, negative 3y plus 7. So you're going to do 4 times negative 3y plus 7 minus 2y equals 0. Okay, distribute the 4, so negative 12y plus 28 minus 2y equals 0. Those would add up to negative 14y equals 28. Plus 28 equals 0. Subtract 28, divide by negative 14. And you get that y is 2. So your y is 2, and then this is where you have to plug 2 back in for y. So if I know that my x is 3 times y plus 7, I do negative 3 times 2 plus 7, which comes out to be 1. So 1, 2 would be my solution. So you have to be careful that you put the x first and the y second, even though 2 is what you got first. All right, so we 1, 2. Okay, and then I'll do a few more examples with you guys. So for this is a basic one where you just plug in negative 2 for y into the other equation. So you'd get 4x minus 3 times negative 2 equals 18. So simplify. This would be plus 6 equals 18. Subtract 6. Divide by 4. And then if x is equal to 3, then your solution is 3 comma negative 2 because negative 2 is the y. All right, in this one, your y is already solved for, so I'm going to replace 5x plus 4 with y in the other equation. So 10x minus 2, parentheses, 5x plus 4 equals 4. So do you see how it became 2 variables, and now it's just 1 variable? That's the purpose. Distribute negative 2, so 10x minus 10x, and then minus 8 equals 4. 10x cancels, negative 8 does not equal 4, so this would be no solution. Parallel lines. All right, in number 3, the x is solved for, so I can replace 3y with x in this equation. So 2y plus, instead of x, I'm going to write 3y equals negative 15. That would make 5y equals negative 15, so y is negative 3. To get the x, I plug negative 3 back in for y here, and I get negative 9. Because 3 times negative 3 is negative 9. -9, comma, -3. All right, for this one, your y is solved for here. So I'm going to replace -3x plus y with y in this equation. So 5x minus 4 times -3x plus 5. Distribute the -4. So 5x plus 12x minus 20. This makes 17x. If I add 20 over, that gives me positive 17. So x is 1. So if x is 1, what is y? Well, if you plug 1 back in for x, up here you get -3 times 1 plus 5, which is 2. So 1, comma 2. And then we'll do maybe one more. So for number 5, so what could you solve for, x or y? It really doesn't matter. You could solve for this x, you could solve for this y, you could solve for that x. I would, if this were me doing this, I would solve for x here by subtracting the y over. So I'd get x equals 3 minus y. Replace that with x in the other equation. I get 3y plus 3 minus y equals 11. That would make 2y plus 3 equals 11. Subtract 3 and you get 8. Divide by 2 and you get 4. So if 4 is the y, 3 minus 4 gives you -1. So -1 comma 4 is your point of intersection. Okay, so I think I'm going to leave our examples at that and let you try more on tomorrow's Edulastic assignment. Okay, have a great day.